So to go mole to mass, what conversion factor are we going to use? If we're going from moles to grams, what conversion factor are we going to use? We're going to use our molar mass. Oh my goodness. So if we're given moles, what units have to be on the bottom? Moles, and then we can have grams on top. And it's always the mass of 1 mole, so it's 1 mole here. And where would this number come from? Where would you find that number? Yes. Periodic table. And that way our moles cancel out. We're left with grams, which would be what they were asking for. So what's the mass in grams of 1.48 grams are moles of iron? So we start with how much we actually have. We have 1.48 moles of iron. So what are we going to do here? Grams of iron on top. So do you multiply or divide? Multiply. And what do you get? Five, 8, so 6, 6. And this would be grams of iron. If you have 3 decimal places, that's fine. So that's moles to mass. If we want to go mass to moles, it's just basically the opposite if we're going grams to moles. Again, the conversion factor that we're going to use the molar mass again. But this time, if we have grams, we start with grams. We know how many grams of a substance we have. What units have to go here? Grams on bottom, and this time moles on top. And again, it's the mass of 1 mole. And where would the mass here come from? Periodic table. So, what? You're confused? No, for this one it's mass to mole. So if we're given grams, and they're asking for moles. What part do you have a question on? Okay. Okay. Oh, did you say how? Oh. How many? Not Santa. How many moles of atoms? So even if it says moles of atoms, we're still asking for moles. If it was asking for atoms, it'd say how many atoms are there? So how many moles of atoms? So how many moles are there in 40.1 grams of calcium? So what units go here? 1 mole on top. Grams of calcium on the bottom, because we need to be able to cancel out our grams. We're left with moles, and they're asking for moles. So do we multiply or divide? Divide. Should be pretty close to 1. because 40.1 divided by 40.08 should be pretty close to 1. 1.000 something, so we'll just say 1.0 moles of calcium. Did that help? Okay. Anytime we're dealing with atoms, we have to use that big number, Avogadro's number. So moles to atoms. What are we doing here? Come on. The conversion factor we're going to use is Avogadro's number. So for given moles, we know how many moles of a substance we have. What units are going to go here? Moles on top or bottom? Bottom. And 1 mole of a substance has how many atoms? Does it matter what element we're dealing with? No. So that's what we'd have. Our moles cancel out. It's always, that's how many atoms are in 1 mole, so it's always 1 mole. So if we do this problem, we're going to determine the number of atoms in 0.25 moles of sulfur. So we have 0.25 moles of sulfur. So we'd have 1 mole on bottom so that our units cancel out. And what goes on top? Avogadro's number. Yeah, I can come over and help. Because you should, well, I don't have my calculator. The ones that are up here? Okay, let me see. Okay, I put parentheses and then okay, I would put parentheses and then put your 6.022 and then push times 10 and then use the little XY button right here that's above the C. Yep, push the XY button and 23. And then parentheses again. And that should show you that number. And then you would, for this one, you'd multiply by 0.25 then. So you should get 1.51 times 10 to the 23rd. 1.51 times 10 to the 23rd atoms. Sulfur. Now atoms to moles. Going to use the same conversion factor, right? We're going to use Avogadro's number again. But if we're going atoms to mole, we're given atoms. What are our numbers that have to go here? What numbers go on the bottom? Avogadro's number, okay. 6.022 times 10 to the 23rd. And on top, 1 mole. That way our atoms would cancel out. So for the problem, if we have, we're going to determine the number of moles that contain 2.56 times 10 to the 24th atoms of lithium. So we have 2. Top left, what do you, okay. So we need atoms on bottom to make sure our units cancel out. There's always 6.022 times 10 to the 23rd atoms in 1 mole of any element. So this time you're going to divide, yes. And you'll probably want both of those numbers in parentheses. $4.25. Okay, next one is atoms to mass. So are we going to go straight from atoms to mass? Can we go straight to atoms to mass? No. Right, this one we have to go, because we can only go atoms to what? Moles. And then we change moles into grams. So the conversion factor we're going to have to use Avogadro's number first in order to get atoms changed to moles. And then we'll have to use the molar mass to get from moles to grams. So if we're going to determine the mass in grams of 4.86 times 10 to the 24th atoms of gold, we know we have how much gold? Oh, we forgot to write, let's write this up here. I forgot to do this. We're given atoms. We'd have Avogadro's number of atoms in 1 mole. So you would divide this, and then 1 mole has a certain amount of mass, grams, and that this mass right here comes from the periodic table, whatever its molar mass is. So if we have 4.86 times 10 to the 24th atoms, atoms go on the bottom. So 6.022 times 10 to the 23rd atoms. And that's how many atoms are in 1 mole. Now atoms cancel out. 1 mole of gold has what mass? 0.95. So now our moles cancel out. We're left with grams, which is what they're asking for, mass in grams. So we're in the correct units. So you multiply by the top and then divide by the bottom number. So you're going to take, and it doesn't matter what order you do it. You can multiply first and then divide, or you can divide and then multiply. Just make sure your two exponent numbers are in parentheses. And yep. It should be larger than 196. $1,589. So the reason that you can look at it and say, well, it should be higher than 196.97 because we have more atoms than we do in 1 mole. So we have more atoms here than are in 1 mole, so we should have a higher mass than a molar mass. Then the last type of problem is mass to atoms. So can we go straight from grams to atoms? No, what do we have to go to first? Grams to moles, and then we can convert moles to atoms. So if we're given a mass in grams, we want grams on the bottom, and that's the mass, the molar mass of 1 mole, and that would come from the periodic table. And then we know how many atoms are in 1 mole. So we actually used molar mass first this time. And then we used Avogadro's number. So this time you're going to end up multiplying by Avogadro's number. Yep.
Why can't we just keep it on the bottom so when it's next to each other you multiply and when it's like across from each other you divide? So you're not using multiplication.
Well, the way you can remember is anything that's on the top you multiply. Yeah. Oh, but you want it right here? You want it next?
Grams to your other grams.
You're going to divide.
And then you go back up.
You can take this grams and multiply first. You can multiply first, and then you can divide if you want. But you want them next to each other.
I'm talking like keeping Avogadro's number on the bottom.
But we can't, otherwise atoms would be on the bottom, and we can't cancel out any units then. So if we have 2.65 grams of iron, since we have units of grams of iron, we know grams of iron need to be on bottom. And, yep, 55.85. And that's the molar mass of 1 mole of iron. So now our grams canceled out. What? our moles cancel out. So you can multiply by Avogadro's number first and then divide by 55.85, or you can divide first by 55.85 and then multiply by Avogadro's number. You'll get the same answer. You get 2.86 times 10 to the 22nd.